Hello and welcome to helpyourmath.com. Let's talk about properties of real numbers. It'll be an absolute blast, so stay with me. We are going to discuss 3 properties of real numbers in this video. The absolute value of a number, the opposite of a number, and the reciprocal of a number. It's going to be so fun. We're going to start with when we write down a number, that number tells us 2 important pieces of information. First, it tells us whether it's positive, negative, or neither. So a number is positive, usually we just write the number. So if I'm said the number 16, that's really positive 16. But because the positive numbers are used so frequently, we don't need to include the adjective positive, we just say 16. If I'm trying to say, no, I'm $16 in debt, then that would be a negative 16, and we will put a little negative sign with it. And there is one number that's neither positive nor negative. Do you know which one it is? That's right, it's 0. So 0 doesn't have a sign. It's neither positive nor negative. We just write 0. The other thing that it tells us is its distance from 0 on a number line. So if we're to look at a number line, remember it should just have even increments. So whatever I'm counting by, I just continue counting by that number. So if I go -3, -2, -1, 0, 1, 2. Okay, so we see here, so you'll notice when I wrote the negatives that I did include the negative sign, but when I wrote the positives, I didn't put +1 and +2. I don't have to do that. We could also see the distance. So if we look at this, the distance that -3 is from 0 is 3. Voila. The other thing you might notice about my number line and all number lines, well, I should say horizontal number lines, is that they always go from least to greatest. So the negatives would always be on the left, 0 would be, in the middle or in between the positives and negatives, and the positives are to the right of 0. We can't ever have a number line that goes backwards. That's just bad math. Okay, so this distance, that actually has a special name. It's called the absolute value of a number. So we say the absolute value of -3 is 3. And we have some notation for absolute value. It's kind of like long bars. So if I say absolute value, those things are called the absolute value bars. And they're a special type of grouping symbol. They're a little bit different than our parentheses or our brackets because we can't do things to whatever's inside. We can't distribute inside an absolute value. We can only take the absolute value of a number and then see what's waiting on the outside. So in this case, it's just saying, what is the absolute value of -3? And we would say 3. If we wanted the absolute value of 3, so what's 3's distance from 0 on a number line, where keep in mind, distance is non-negative, meaning it can't be negative. 3 is 3 units from 0 on a number line. You'll notice I was very particular about saying non-negative and not positive because the absolute value could be 0, which again is not positive. So if I say non-negative, that's just me referring to 0 and all the positive numbers. If I say positive numbers, I'm excluding 0. And fun fact, as I mentioned, the absolute value bars are a special type of grouping symbol, meaning that if we see them in a problem, we evaluate what's inside of them first. We would take the absolute value and then carry on with the problem. Okay, so let's look at some examples of finding the absolute value. The absolute value of -7. So how far is -7? What's the distance between -7 and 0 on a number line? It would be 7 units. How about 2 3/10? 2 3/10 would be 2 3/10 away from 0. And then here we have we have a little situation here. But again, referring back, it is a grouping symbol. So we start inside. 5 minus 9 is -4. Now we have the absolute value. I haven't actually taken the absolute value, right? So if I haven't done the thing yet, I keep writing it in the problem. I haven't taken the absolute value. All I've done was subtract inside. Now I'm ready to take the absolute value. The absolute value of -4, that would be 4 units from 0. And then the minus just stays because it's not inside any absolute values. And then the absolute value of -7 or -7 is 7. Now I'm ready to subtract. 4 minus 7 is -3. Sometimes students say, whoa, wait a minute, but there were absolute values in this and we can't have a negative. Sure we can. We just can't get a negative if we take the absolute value of a number, but our answer could be negative. We have 4. We're taking away positive 7. We absolutely can have negative 3. No problem. The next thing we're going to talk about, so we've talked about absolute value, is the opposite of a number. This is specifically the additive opposite, but usually we just refer to it as the opposite. The opposite of a number is the number with the same absolute value of the given number, but with a different sign. And this can be a little bit weird because the notation we could use for opposite already has 2 other meanings in mathematics. So just to give you a third meaning for this sign, we could also read that sign as the opposite of. So if I had something like this, we could interpret this as the opposite of 7. And the opposite of 7 we know to be the number negative 7. Also, if you're a non-native English speaker, I do use negative 7 and minus 7 interchangeably, just because I find some students are more familiar with minus 7. But if I say minus 7 or negative 7, those mean the same thing. Minus could also mean subtraction, but so could that sign. Okay, so let's identify the opposite of each number. The opposite of 8 is, say it with me, negative 8. The opposite of negative 1.79, so if we're on a number line, draw a number line, there we go. And here's 0, and here's negative 1.79, right? It's negative, so it's to the left. Well, this has an absolute value of, whoops, let's get to 0, has an absolute value of 1.79. What else has an absolute value of 1.79? That would be this number here, positive 1.79. So the opposite of negative 1.79 is 1.79. Oh my gosh, what's going on in this last example? We're going to start from the inside and work our way out. So inside the parentheses, we just have the number negative 4. Inside the brackets, this says the opposite of negative 4 is 4. Then inside the braces, we have the opposite of now 4, which is negative 4. And finally, we have the opposite of negative 4, which is 4. If worse comes to worse, you can always flip a coin and decide whether it's 4 or negative 4. I'm just kidding, don't do that. We can work through this, no problem. Some students also know a shortcut for something like this, which is because there are 4 negatives, you might recall from multiplication of integers, if there are an even number of negatives, the end result will be positive. And fun fact, 0 has no opposite. Yay, 0! Anytime there's something special, it's usually 0. Okay, so now we're going to combine everything we've just done, absolute value and opposites. Okay, this one we start inside the absolute value. I mentioned before, we cannot get that negative that's in front through the absolute value barrier. Nope, can't do it, no chance, no, 0, no. What we're going to do is we're going to work our inside. So the inside we have negative 9. We want the absolute value of negative 9. The absolute value of negative 9 is 9. However, there's a negative in front of the absolute value bars waiting for it to come out. Or we could say, this actually wants the opposite of 9. Either way, our end result is negative 9. In the next example, we have a negative 14 inside the parentheses, and this we could interpret this as the opposite of negative 14, which would be positive 14. Over here, this is absolute value. This is different. We must do the absolute value first, and then we're going to subtract in the end. So that minus sign being in between the two things stays in between. We take the absolute value of negative 3, which is positive 3, and we end up with 14 minus 3, which is 11. If you need to pause on this one, because I know this can be really confusing, sometimes we say, no, it's minus negative, but that's not negative 3. It's the absolute value of negative 3, which is positive 3. Hopefully that makes sense, because I know that one can be weird. Okay, so we've already done absolute value and opposite. We have one left, but before we get to that, in order to be successful with reciprocals, we do need to just do a review of multiplying fractions. So when we multiply fractions, we multiply the numerators together and we multiply the denominators together. Very important here, we do not need a common denominator. We can multiply straight across, and actually, I don't even multiply first. I first try to simplify if I can, which I'm also allowed to do. To simplify when we're multiplying fractions means that I'm looking for a common factor between any numerator and any denominator. We'll see that in the third example. And then one more thing to notice, like what I noticed in the second example, is that, wait a minute, I'm trying to multiply two things, but one of them is not a fraction. What do? You turn it into a fraction. So if we're trying to multiply and one of the things is not a proper or improper fraction, please rewrite it as a proper or improper fraction. Usually it would be an improper fraction. But in our first example, the numerator has factors of 5 and 3, and the denominator has factors of 8 and 7. Now 5 and 3, neither of those have anything in common with either of the factors of the denominator, so we multiply straight across. 5 times 3 is 15, 8 times 7 is 56, and that would be it. In the next example, as I mentioned, we want to turn 9 into a fraction. How do I do that? That's right, we put it over 1, and then we're going to multiply by 6 over 11. Now 6 and 9 are my factors of the numerator. They do not have anything in common with those two factors of the denominator, 1 and 11. Well, of course they do, they have 1, but we don't care. So we'll multiply straight across. 9 times 6 is 54, and 1 times 11 is 11. I love improper fractions. I think they're wonderful, delightful, and there's nothing wrong with them. If you feel like you must convert it to a mixed number, you're welcome to. But again, I stand by 54 over 11 being totally acceptable. Just to review, we would convert this into a mixed number. So remember from the previous video, I said that fractions, the fraction bar is a division. So this really means 54 divided by 11. How many whole times does 11 go into 54? Oh, it's so close to 55, but not quite. It goes in 4 times. Those 4 11s give me 44, but I'm trying to get to 54, so I still have 10 left over. 10 goes in the numerator. And when we're converting between improper fractions and mixed numbers, the denominator is always the same. So I stand by 54 over 11 being totally fine and acceptable, but if you must, you can rewrite it as 4 and 10 over 11. In our third example, I have a 4 in the numerator, which I can simplify with the 4 in the denominator. When we simplify through multiplication, the simplified things, when they cancel out entirely, become 1s, because 1 is the multiplicative identity. The 7s also cancel out, so those also both become 1s. And now what I have in the numerator is 1 times 1, and in the denominator I have 1 times 1, and 1 divided by 1 is 1. Now, if you tried this on your own and you multiplied and got 28 over 28, well, 28 divided by 28 also equals 1, so we still end up in the same place. Perfect. And then our last example, we're going to expand and multiply. So this is an exponent, and the exponent says, write the base that many times through multiplication. So we have 1 1/4, 2 factors of 1/4, 3 factors of 1/4. We multiply straight across. 1 times 1 times 1 is 1. You can multiply 1s all day long, but you're never going to get anywhere. And 4 times 4 times 4, be careful, this is multiplication. 4 times 4 is 16, and 16 times 4 is 64. Okay, so now that we've had this delightful intermission of multiplying fractions, why do we need that? Oh, because it's going to help us with reciprocals. Two numbers whose product is 1 are called reciprocals of each other. Oh, there they are. So we had that 4 over 7 and the 7 over 4. That would be a pair of numbers that are reciprocals of each other. If you wanted a notation, so if I wanted to ask a question that said find the reciprocal without using all those words, because that is a lot of words, what we could do is I would put it inside parentheses, and then we raise it to the -1. So raising something to the -1 is another way to say take the reciprocal. Once you raise it to the -1 power, that means take the reciprocal, and there it is. Okay, cool. How do we find the reciprocal of a number? We want to write the number as a fraction, either proper or improper. Wait, hold up. What's a proper fraction? What's an improper fraction? A proper fraction, so let's say the fraction we're dealing with is a over b. A proper fraction means that the value of the numerator is smaller than the value of the denominator. So we would say a is less than b. So proper fractions, we could have, let's go back here. Let's look. 5 over 8, so 5 is smaller than 8. This is a proper fraction. 3 over 7, 3 is smaller than 7, so it's a proper fraction. Over here, 6 over 11 is a proper fraction. If we look at this 9 over 1, nope, 9 is bigger than 1, so it's not a proper fraction. 4 over 7, 4 is less than 7, so it's proper. 7 over 4 is not, and then 1 over 4 is a proper fraction. So those are some of the proper fractions. You'll notice that the numerator is smaller than the denominator. How about an improper fraction? So an improper fraction is when the numerator is greater than or equal to the denominator. And looking back, so the 9 over 1, 9 is bigger than 1, so that's an improper fraction. Over here, 7 over 4, 7 is bigger than 4, that would be an improper fraction. If we were using that fraction that looks like a 1, if we had, 6 over 6, this is also considered an improper fraction because the numerator and denominator are the same. So when we have that equivalent to 1, that's an improper fraction. Now, the next thing that we would need to know, so proper fractions are proper fractions. The only thing that we might be able to, the only issue we might have is that we might be given a number that's a decimal, in which case you would need to rewrite it as a proper fraction. If we're given other types of numbers, we might need to switch them to improper fractions. So we already saw that with the 9. So for integers, you would just need to put it over 1. Like the 9 we put over 1, that created the improper fraction. If we had negative 17, we would put negative 17 over 1. That turns it into an improper fraction. The other type of number that we've seen is a mixed number. And for a mixed number, let's just say we have 4.5. What we do to convert a mixed number into an improper fraction is we multiply the denominator by the integer. The integer is I would call it the big number. And then we take that result and we add the numerator. So in this example, 2 times 4 is 8, plus 1 is 9, and we keep the common denominator. So if you need to practice that, this would be a good time to pause and practice just converting between mixed numbers and improper fractions. It can seem weird, but once you get the hang of it, it's not so bad. Okay, so if we're given a mixed number, we need to write it as its equivalent improper fraction. So 4.5 is equal to 9 over 2. Those represent the same value. Those are not the reciprocal. Okay, so what was the whole point of this? Oh yeah, we're finding the reciprocal of a number. We're writing the numbers either a proper or improper fraction, and then we're going to switch the values of the numerator and denominator. This is the step that is the reciprocal. The first one, we're setting up the number, but we're keeping it the same. Now to find the reciprocal, we switch the values of the numerator and denominator. Okay, so let's look at some examples. First up, we have 7. First, we need to rewrite it as an improper fraction. 7 is the same as 7 divided by 1. That is the number itself. The reciprocal of 7, we're going to switch the values of the numerator and denominator, is 1/7. So we could say 7 to the negative 1, because remember that was the notation, equals 1/7. You probably don't have to do that. You just need to indicate that this is your final answer. One thing that I see students do, because they're like, I got this, and then they say 7 equals 1/7, and I'm like, no, that's not great math. So that's why I like the notation, because if you insist on like saying something equals this, cool, but at least make it mathematically accurate. That is one thing that can look weird when you're trying to say that 7 equals 1/7. So either don't put an equal sign at all, or use the notation, or just write it below where you're not saying something that's totally wrong. In letter B, whoops, there's that mixed number we were talking about. Do you remember how to switch it to its improper fraction? We start with the denominator 5. We multiply the denominator by the integer 4, that's 20. Add the numerator, that's 22. Keep the common denominator 5. We have 22 over 5. That is equivalent to 4 2/5, so we haven't found the reciprocal yet. This is only step 1. Now we're going to switch them, and that's going to be the reciprocal, and we would get 5 over 22. If you wanted to say equal, you would do the 4 2/5 raised to the negative 1. In letter C, we have 0. So 0 is an integer. We would write it as 0 over 1. And then we would say, okay, well, the reciprocal is when we switch the values, but 1/0 is not a number. That is not defined, not a thing, does not exist. Nope. So again, we've seen this again with absolute value. We saw it with opposites and again with reciprocals. There's always something about 0. 0 does not have a reciprocal. No reciprocal. And in fact, it is the only real number that doesn't have a reciprocal. Poor 0. All right, letter D, 5/8. So 5/8, that's a proper fraction, the only proper fraction on this page. And all we need to do is write 8/5. And again, don't be tempted to say equals 8/5 because look at that. Now you're saying 5/8 equals 8/5. That's terrible. Don't do that. No. If you need to put those equal signs in, what do you say? You say 5/8 to the -1 equals 8/5. There we go. You get your equal sign and you get it mathematically accurate. Yay! Win-win. In letter E, we're presented with something new. This is the first negative. So there's a couple different things that we might notice. Every improper fraction has a reciprocal that's a proper fraction. All the reciprocals we've seen so far have been of positive numbers and all the reciprocals have been positive. Here in letter E, we have a negative. The reciprocal will also be negative. So we can rewrite -16 because it's an integer as -16 divided by 1. And then the reciprocal, we're going to just flip that around. And you can put the negative out in front of the fraction if you want. You can keep it with the 16. You can put it up with the 1. We just need that one single negative. It doesn't matter where it goes. Usually we just put it in the middle, but again, that's not a big deal. In letter F, okay, wait, we don't have an integer this time. We have a decimal, and in fact, it's going to be a mixed number when we see it up close and personal. So we have a couple different things that we could do with this one. We do need to convert it to an improper fraction, and however you want to do that is fine. What I like to do is I just read this one, so it's 1.1, which is not great. This 1 is in the tenths place. So we could rewrite 1.1 as 11/10 because the tenths place is the least place of this number. And that's it. And now we have the improper fraction that it is. The other option would be to rewrite it as 1 1/10. But then you would need to rewrite it as 11/10 anyway. So we're better off just kind of removing the decimal because the decimal just says, okay, now we're going to start dividing by 10. Powers of 10. Since we only had one place behind it, we used the first power of 10, which is 10. I haven't yet found its reciprocal though. Have you? If you said 10/11, you, my friend, are correct. So in this video, we looked at absolute value, which 0 had something special about it. We had opposites, which 0 had something special about it. We looked at reciprocals, which 0 had something special about it. And every other number is special too. I hope you found this helpful. Thank you so much for stopping by.